Okay, so let's continue with some more factoring work. So we've got our factoring by grouping sort of down as a process. We said this is a good strategy for if we have just sort of right off the bat 4 terms. The kind of implication there to a certain extent is that you would be starting with a cubed term and going down to a constant term. In theory you could do that with a higher degree polynomial where you had more x's, going from an x to the 5 down to an x squared or something, right? In theory, you could kind of do this with higher degree things also. We're probably not going to see that as much. So instead, let's focus on quadratic. So quadratic is a degree 2. So our form is ax squared plus bx plus c. So a and b and c here are constants. X squared, x obviously are variables. So let me put an example down. We'll sort of work through one as we talk through the process. So let's say 3x squared minus 4x minus 4. Right? So the idea here is you've got kind of A, B, C, right? A is 3. We're going to keep track of the signs, positive or negative. So A is 3, B is negative 4, and C is negative 4. So this is 3 terms. We sort of have right off the bat, we just can't do this grouping step, right? It's just not possible because we don't have a 2 and a 2. We don't have that balance. The strategy here is going to be to actually take this middle term, this minus 4x, and try to split it into 2 terms. But we need to do it strategically so that when we split it, we're actually going to have some luck trying to factor it. If we just sort of pull numbers out of a hat, this is not necessarily going to be possible. Obviously, I've sort of picked an example more strategically, and so it is going to work for us here. We need to go through the steps. So our process here is to look at first the a value and the c value. So calculate a times c. So for us, right, that's 3 times negative 4, which would be negative 12. And so what we're looking for is we need 2 numbers. We need them to multiply to this product, a times c, which for us is negative 12. And then we need them to add to whatever our value is for b. So the b value here is going to be minus 4. So this is not quite a guess and check process. There, I guess to a certain extent it is. There's definitely a certain amount of checking. There's not really guessing. We're going to have to sort of think about all the possible pairs that would multiply to negative 12, and then we need, in theory, there should be kind of one or only one that multiplies to negative 12 and then is going to add to negative 4. You're probably in your seat now, yelling out the answers, I'm sure. But I'm going to pretend like I can't hear you, and we're going to sort of run this a little bit sort of longer. So let's take, so AC is negative 12. So let's just brainstorm a couple pairs. Can we hit all of them? I don't know. We'll see how much space we have. So to a certain extent, I suppose obviously negative 1 and positive 12. positive 1 and negative 12, right? So 1 and 12 is obviously going to be a pair. We could do 2 and 6, so negative 2. There's positive 6. Flip the signs, 2 and negative 6. Positive or negative signs here make a big difference, right? You have to track your positive or negative signs. In this case, right, our sort of multiply value is negative, so all of our pairs we're going to have sort of one negative number and one positive, and we need to sort of check it from both directions. As we go through this, let's check the b value. So we'll sort of say adds to b, which is supposed to be minus 4, question mark. So in this case, pretty quickly we can see, right, negative 1 and positive 12 is definitely not negative 4. That would be positive 11. If I come at it from the other direction, positive 1 plus negative 12 is negative 11. Definitely not negative 4. So that's a no. That's a no. Negative 2 and positive 6, that's kind of in the ballpark, right? That would be positive 4. So it's the right number, but it's not the right sign. That fills me with hope that if I do positive 2 and negative 6, I'm going to hit negative 4, and that's a bingo. So once I hit a pair that works, I don't need to check for any other numbers. Once I know that I have a pair that works, I'm pretty much good to go. I'm going to use that to rewrite my middle term, and I don't need to check any other numbers. In theory, we could have had a 3 and a 4, right? Sort of each positive and the other negative. If you think of what you would get if you added a negative 3 and a positive 4, or vice versa, you would get obviously positive or negative 1. That's not going to hit negative 4 anyway. There's a little bit of a luck of the draw in terms of what's the order that you sort of check these. It could be the case, and probably to a certain extent, once you get used to this process, you'll probably be able to mentally figure out what numbers are going to work and what numbers aren't. You won't necessarily have to write out the full table. It's never a bad idea to write out the full table just to make sure you're not overlooking any numbers. 1 times the number itself is often one people overlook, and sometimes there's other ones in the middle. It always depends on just how many different factor pairs you could have. So what we're going to do is we're going to rewrite. So our original 3x squared minus 4x minus 4. So I'm going to rewrite this middle term, and I'm going to use these two numbers. And in particular, right, what I'm using here is I need them to add to negative 4x still. So that's still extremely important. I'm not trying to sort of change my actual values here. I'm just trying to change the way it looks. So negative 4x would be plus 2x and then minus 6x. So let's just sort of write that in. It doesn't particularly matter the order that we put these. We could have done minus 6x first, and then plus 2x after. In theory, it should work either way. It's not a big deal. Once I have this set up, this sort of expanded form, now I have 4 terms, and I can look to do my factoring by grouping. So the same exact steps that we were doing in our longer example from the last video. So I'm going to look for the GCF from my first 2 and from my last 2. In theory, right, again, if you flip the order here, you could sort of go through this exact same process. You would get slightly different pairs and GCFs and sort of looks, but your final answer should end up in the same spot. So what do we have in common? So 3x squared plus 2x, 3 and 2, nothing in common, but they do have x in common. So I'll take that x out in front. Not a whole lot to work with there, but we'll play the cards we're dealt. We'll go from there. 6x and 4. Again, not tons and tons to work with. It's not necessarily about hitting like a really big GCF. Again, it's just sort of a matter of working with what you've got. So if you don't have a ton of stuff that's going to factor out, that's fine. In theory, you could have something where there are no terms in common and you're just factoring out a positive or a negative 1. kind of a trivial GCF. That can happen, so don't be alarmed. In this case, 6 and 4, they're both even numbers, so we could at least factor out a 2. And then my suggestion, right, is if this third term is negative, bring the negative out in front with your GCF. You're going to have to sort of pay attention a little bit when you do that to what happens on the inside. So if I do negative 2 out of negative 6x, so negative comes out, which means I'm left with a positive 3x. You can imagine if you remultiplied negative 2 times 3x, you'd end up with negative 6x, back where we started. And the thing that people often overlook, the most sort of tricky thing to remember, is then if you look at the second number, so this is supposed to be minus 4, if I take a negative 2 out of here, so obviously 2 out of 4 would leave me with 2. If I take the negative out also, then this is going to be a positive 2, plus 2. That's important because it matches the one that's over here. So to a certain extent, you can kind of know what to expect based on what your sort of previous setup was. From here, we're kind of one step to the end, right? So now we just need to sort of factor out and say, okay, so my GCFs here in green, they're going to come out in front as their own term, and then my matching chunks here in the parentheses, 3x plus 2, are going to come out here on the right. So we're sort of factoring this out to the right, and then we have our leftovers, these two GCFs, come together as their own term. So our factored version becomes x minus 2 times 3x plus 2. You can double check this, you can sort of FOIL it out or use our box multiplication to sort of multiply this out and make sure you would end up back at 3x squared minus 4x minus 4. I'll let you kind of check that on your own as an exercise, I guess, if you're looking for some math exercise. But that's the basics of it. So we're kind of using this a and the c term together, multiplying them together to find our the number we need to sort of factor down. We get our sort of factor pairs, the multiplication pairs, to get to negative 12, and then we need them to add up to that number in the middle. And that's the idea.